Okay. uh, Activity 3 is not yet visible actually on your Blackboard because I don't want you to be doing anything during the Holy Week. Okay, kasi parang ano yun, it's basically solemn. Okay, so we just have it done by next week. But I will be explaining the process now. That way, you have more or less an idea already on what to do for the activity. So let me share the activity I have already posted on your Blackboard. So although this is not yet visible on your end, because I set a certain date for it to be available. Okay? Wait lang. Share ko yung screen ko sa inyo. Showing you the Blackboard and the activity 3, no? That you will be doing. So if you're not yet through with activity 2, then you still have a lot of time to do so and submit activity 2. Okay, so share ko lang yung screen ko sa inyo. There. You should be seeing a my Blackboard placed on week 6 tab. Okay, so this means this will appear on your week 6 tab. Nandito siya sa week 6 tab nyo. And notice it's not highlighted because it's not yet appearing on your Blackboard. No? So it will appear by April 6 pa. Okay? By next week pa, technically. Because I don't want you to be doing anything on this week. Okay? So tingnan lang natin what to expect for activity 3. So activity 3 deals with discrete signals and discrete time systems in your MATLAB. Okay? So for this given activity, again, you will be asked to basically plot and create signals like what you did on activity 2. But except this time, this would be discrete signals. So we need to create a random signals, and from there, we will apply this following operations, signal operations for discrete signals, which is from A to E. Okay. Again, you don't need to write a script in order to show me how this particular operation is done and how it can be plotted. You don't need to create something so complicated like that. Remember, you can make MATLAB work much like a calculator for you. Nakuha ba? Okay, so makikita kaya yung aking senior na nandito. Ayan. Can you see my MATLAB? Which is hanging. Nakikita nyo ba? Ha?
Yes, sir.
Yes, sir.
Yan, sige. Okay, so nakikita nyo na. So on the MATLAB, basically, you're allowed to create signals, random signals, as dictated on our Blackboard, no? So kasi dito sa Blackboard natin, ang banggit sa Blackboard, we need to create random signals, no? With these amplitude values, 9 samples of them. Okay, 9 samples with this amplitude. So you're given your seat number, the maximum amplitude would be this value, no? So your seat number multiplied by 0.3. That would be your maximum value. So that's basically a cap limit, no? So here, you could actually create any random signal. Okay, so gawa tayo ng random signal. Let's say, mag-assign lang ako ng size. So isang row lang to with 9 values na random. Okay? So, MATLAB will then display to me and give me 9 values. Ayan. Randomly generated 9 values pero wait lang. Gusto ko may negative eh. So, gagawin ko lang, mag-subtract lang ako. do that. Minus 0.5. Yan, para may negative na values lang. Okay, ayan. Nilagyan ko lang na negative values. Gusto ko lang may negative, wala lang. Okay? And then technically you could plot this. Okay? Now if you just simply plot this like wait, dapat pala nag-assign ako ng variable, no? Sorry. Clear ko lang. X is equal to any random value. So isang array ng 9 values minus 0.5 na para sakto na. Para may negative. I just want to have like negative numbers. Yeah. Okay? Para lang may negative. Kasi puro positive yung ilalabas niya pagka random values. So I just place there para may negative value. Then I could plot this, but the problem is if you simply type the plot command, like for example, plot x. Okay? Pinat ko lang yan, ganyan. Then eventually, MATLAB will give me something like this in a figure. And the usual case is that he connects all your plot values using a straight line. Ganyan mangyayari, no? This would be the outcome if I just use that plot command. So wherein these are these discrete values, ito yung mga discrete values ko. Actually, I could click on the value and then run through the graph, and you would see the plot values that are given by MATLAB from until negative yan, ano? So ito mga negative values ito. Ayan, nakita ba? Nasundan? So because he automatically connects that into a function, no? Basically like that. So but I don't want something like this, no? Ayoko nung yung plot na ganito because this is obviously not a discrete plot. Okay? So what we want basically is like a stem diagram. So luckily, MATLAB has that. Okay? MATLAB has that stem diagram that we could eventually plot. So pag tinype ko ngayon stem, he plots the values of x in a stem diagram now. Okay? Ayan na, which is more or less a discrete value that we eventually have learned. Sorry, on your lesson, no? If you're under me in the lesson, I already discussed about stem diagrams there. And I've already discussed how to operate, how to do operations on discrete signals there. Okay, so ayan. This looks more like a discrete signal now. Nakuha ba? Okay. By default, if you do not place in values there, he automatically sets the values of your discrete values that you have at a given definite value of n. So in this case, my value started at n equal to 1. No? So allow me to write down here. Anong color ba to? Red. So here, n is 1. Diba? Kita naman dito. At ang amplitude ko is this. Oh, somebody is at the waiting room. O yan. At ang amplitude ko is this on 1, which is the first value on my MATLAB sequence. Nakuha ba? Let me scroll here to show that to you. I-scroll ko lang to a bit. Ito, yan. Annotate ulit tayo. No, wala. Wait. Nag-i-scroll down ako eh. Oh, pag nag-automatic siya doon sa next slide, next line. Oh, anyway, as you can see here on the values below, pakita ko na lang. The first value here is around 0.3308. Okay, eto siya, no? So eto ngayon yun, 0.3308. Nakuha? Followed by 0.0853, which is this value, and so on and so forth. So he automatically places this at n equal to 1, n equal to 2, n equal to 3, n equal to 4, and so on and so forth. No? Nakuha ba? So, but what if what I wanted to do was, ang gusto ko, let's say, I place this in the middle of my, it's more or less a discrete time, you know, itong 0, 1, 2, 3 to 10, no? It's your discrete time. And I want the middlemost value placed at 0 instead of at n equal to yung middlemost value, which turns out to be the fifth value, no? So here, our fifth value is negative 0.2142. That's the fifth value on our data. And I want that placed at n equal to 0. Nakuha ba? So, paano ko gagawin yun? Basically, there's a trick to that, no? If you want to do that. So, pwede natin gawin yon. Wait, let me just clear the annotation. Nakakarang yung annotations ko. Okay? So, by adding a certain parameter. Okay? The parameter would be plotting stem and then placing a range of values. I think it's in closing braces. Okay, so this basically locates the plot, no? So for example, for ano to, negative 4 to tama ba? It should be negative 4 yata. 4, 1, and 4. Okay, tapos X. Yeah, I think that's the correct syntax there. Okay. So from what you see now, you could obviously note that I have placed the negative 2 point something value natin now at n equal to 0. Nakita ba? Tapos yung highest value natin, which is ito, actually mas maganda kung may space pa. So pwedeng 5, negative 5 to 5. No? Ang increment dito, ang syntax ko is increment of 1. This is the lowest value, the highest value of x. Nako ba? The lowest value range here on the left would be negative 4. The highest value here would be positive 4. And I will fit all 9 data there at an increment of 1. So, sakto naman yun, di ba? I have 9 elements, di ba? Okay, o yan. Ganyan, basically like that. Okay, so ganyan siya. So, actually, this is simply a range of value that you could declare later, no? Pwede mo na ma-declare to as separate depending on the range of value that you want. Meaning, literally, when you perform like shifting process on your MATLAB, you just simply alter this. Ito lang papalitan mo. Ayan lang. Because this is where the values are plotted. Nakuha ba? This is the location where the values would be plotted. So when you do like shift to the left or shift to the right, okay, like the one in given on some of the instructions here on your exercises, then you could manually place them like this, as simple as this. You don't need a code. Yun nga yung sinasabi ko eh. You don't need a code to plot that. Nakuha ba? You need a code to plot it if you want it done in varying shifts. Nakuha ba? Gusto ko iba-iba yung shift. Gusto ko maglalagay lang ako ng value ng n, yun yung shift, sir. Tapos, I could plot the signal at any given shift value. O yung pwede. Nakuha ba? Nasundan niyo yan? Okay, no? Okay yun. Maganda nga yun. Talagang napaka-ideal nung, nung solution na yan. No? I would obviously prefer that, but that would be a bit complicated to do, no? Because I haven't considered script writing to you yet, no? So basically, parang ina-assume ko you have zero knowledge regarding script writing, especially on MATLAB. Nakuha ba? Okay, so oh, what I wanted you to do is typically make MATLAB work like a calculator for you, no? Kagaya nito, I just place there the values, then I simply type the command for plotting it, then that's it. Ayun na. Nakuha ba? As simple as that. So ano yung mga commands ko? Di yun nandito sa script ko. The one found on my script, that would be my simple command there. Nakita ba? So you don't have to make a very complicated ano no uh, command script for that. Nako ba? So meaning if I wanted to shift my values, I could simply change that range of value. Nakuha ba? And since there are no values preceding my given random values, then eventually I could like have it done as zeros. No, by default zeros kasi uh, in any case nothing will be plotted anyway on my graph because those values of time signal integer n won't have any value on them. Nakuha ba? Kasi na-shift nga. Okay? So, uh, if you are familiar with that operation, no, regarding shifting. Okay? So kasi pagdating natin dito sa wait, I cannot access that because of the toolbar nitong ano eh, Zoom, which is getting in my way. Binaba ko na. There. Hindi ko naman kailangan itong part na to. Ayan, makikita niyo naman ano. When we do these different operations involving your signal like this, this, ito shifting, okay, shifting, ako ba? So yun yan, no? The first one is basically referred to as folding, okay? So this one is referred to as folding. Ito yung tamang term dyan, you know? Literally tinitiklop, parang ganun. Or flipping. Actually, the MATLAB command there is flip. Kasi fini-flip niya yung signal. So that's the command there ng MATLAB. Then here, it's called scaling. Ito naman, time scaling ito eh. Okay? Again, there is no distinct MATLAB command for doing time scaling. You have to do this basically manually, which eventually allows you to dictate the time scale or the integer time n. So 0, 1, 2, 3, ito yan, you know? Nakuha ba? Eh, nadidictate mo naman yan, di ba, sa command ng sinabi ko. Nakuha? So, nadidictate mo rin yung scaling. Okay? As well as, likewise, itong shifting. So, this is referred to as shifting. So, this is basically called downscale. Downscaling, ito ang tawag dito, upscaling. Okay? You termed as upscaling. This one is called shifting. There's a shift left, shift right. This is a shift left. And this one is a shift right. Meaning you shift the signal to the left and you shift the signal to the right. So ganun siya. Basically, no? That's how we apply manipulation of signals in operations on discrete signals. Okay? Or you'll be doing that, no? So how do we perform those tasks? So yun ang tanong, no? Okay? So again, you need to know the different MATLAB commands there, and those commands like the flip left right, okay, the folding, okay, which is actually ito yung command dyan, is not actually found on your PDF. Okay, because it's actually more embedded on the DSP toolkit. So we have that DSP toolkit, then you could see those commands. Actually, you could use help anyway, diba? For the toolkit, you could use help there, okay? On the DSP toolkit. Actually, if you go over to MathWorks, makikita niyo yun. Okay, o balik tayo. So we now know how to basically plot this using a stem diagram. Actually, we could set this n values here. Whenever you plot it, of course, the values of x comes first and then followed by the values of your y. Ganun siya, no? Pag pinaplot nyo. So, under MATLAB, no? So, ito yung values ng x natin, which is yung time scale natin, which is -4 to +4. Ito yung amplitude natin, which I called x, no? Actually, kasi ang ginawa ko lang variable x. Naku ba, you could call that y if you want, no? Di ba? Para hindi ka nalilito na y values yan. Okay? It can be called any variable, no? Tinawag ko lang x. Pwedeng a, pwedeng b, technically, no? Naku ba? I just called it x, pero hindi siya x values, no? It's actually amplitude values or y values. Nakuha? Okay, so any question there? May tanong? Wala. Okay, malinaw pa so far. Okay, so when we perform like, for example, those different commands, you could apply, so ito yung sinasabi ko nung flip left right. Ay, sorry. left right. Left right, if i-flip natin yung ating x. Yan. Okay? So, basically, the values now, kung napansin nyo, are now arranged in a reversed order. Nakita ba? Nakita? Okay. So, flip ko. Left, right. Okay? Flipping left to right means all values on the left will be turned to the right. So, I ended with this one, which is this. Diba? Followed by this, which is now this. Nakita ba? So, pinagpalit ko. Okay? Oh, I hope you okay, so ayan na, nabaligtad basically, no? That's the whole concept. Kasi when you do negative n, basically you fold the signal. Okay? So let me show you how it's manually done. No? Basically, for example, I have this signal on 0, which is, let's say, ang amplitude ay 1. Then I have on 1 a signal which is -1. Tapos 0. And then 1 ulit. Ayan, kunwari ganyan yung signal ko. If I flip this left-right, the term is fold, no? The term is fold. If I do that manually, then on my graph, 0 will still be 0. 1 pa rin yan. Nakuha ba? But on my time scale na 1, mapupunta sa -1 ngayon yun. Yung time scale ko. So magkakaroon ngayon ako dito ng -1. Tapos magkakaroon ako ng 0 dito. And then here, I'd have +1. So this is for -2 and this is for -3. Nakita ba? So when I fold it, when I fold that signal, this original signal that I have for xn, when I fold it, this becomes x negative n. Yun yung tinatawag na x negative n. Nako ba? And the command there, notice no, the command there is simply flip left right on your MATLAB. Okay? So basically folding. Tapos, I could like plot this. Okay? So again, using the stem, ipa-plot ko lang to. So, stem plot ulit tayo, no? Again, always use a stem plot command, no? Kasi we're dealing with ano dito eh, no? We're dealing with discrete values here, no? It's not a continuous signal. Okay? So when you deal with discrete values, always ang plot nun is a stem. Nakuha? So ayan uli, if I plot that on a stem, so my new values would now look like this. So ayun na, nabaligtad na. Oh. Hindi na baligtad, sorry. What I should have written is stem, tapos embed ko yung command na flip. Okay. So, sorry. Hindi na ano. Lagyan natin dito yung flip. Ayan. O, na-flip na, no? Nakita ba? So, my value nung positive 4, which is yung 0.3, is now seen on my negative 4. Okay? So, yung nasa positive 4 ko kanina, napunta sa negative 4. Nakita ba? So, na-flip on the y-axis. Nakuha? Okay? So, na-flip lang sa y-axis yung aking graph. So, again, no? All you have to do is to type, actually you could do this one at a time. You could flip left right, assume a variable here. For example, a is equal to flip left right of x, di ba? Then stem, then comma a. Pwede naman ganun eh. Nakuha ba? I just in-incorporate ko kasi para mas madali lang, ano? Basically like that. But I could declare that flip signal into a variable and then plot that. Okay? Instead of incorporating all that command on a single line. Kasi wala lang, tamad lang si sir. Tamad lang mag-type si sir. Ayun. Kaya in-incorporate ko lang dyan, no? Pero mas maganda kung one at a time nakikita, no? Basically. That way, you could reuse this flip signal over and over. Kasi you might be needing this flip signal again. So it's already stored on a variable. Kunwari, ginawa ko yan, A. So yan at si A. Every time I need that signal na baligtad, which is flip, I just call A. Di ba? Ganun kasi siya eh. Nadideclare kasi siya as a variable. You know? So that array. Nakuha yan? It's easier like that, no? Rather than incorporating it all in one signal. Kasi because if you do that, you keep on doing that command. Uulit-ulitin mo yung command, no? While embedding that on your plot command. Okay? So, ganyan siya. So, meaning, sabi ko nga, if I wanted to shift this, let's say one scale to the right, okay? So, I'll just move the x-axis. Nakuha ba? One scale to the right. Okay? So, ganun lalabas, no? And plot those range of values. Okay? So, which means that I'll just alter this range of value. So, if I flip that, let's say one shift to the right, yung signal ko. Okay? Uh, Ulitin ko lang. But this time, I'll have this like shift to the right. So magiging -3 to +5. Diba? Sinip ko sa right. Eh. So what happens now to my signal? Oh, ayun na, na-shift lang. Diba? Nakita nyo, gumalaw lang. So the signal now started at -3. Ito na, which is 3 na to, di ba? All the way to 5 na. Di ba? Because there are 9 signals. Eh. So na-shift na. Nakuha ba? So, ito yung originaling zero value ko. Napalitan ngayon. Ito na ngayon at n ang 0. This value now. This amplitude here become n at 0. Nakuha yan? So, this is like shifting already. So, ano lang yung ginawa ko? I just move this value. Ito. Pinalitan ko lang yung range ng value. Na-shift ko na siya. Diba? So, meaning, again, I don't need to create a script in order to shift that. Nakuha ba? Okay. Now, when we do time scaling, usually you either do compression or you do expansion of the signal. Okay? Compression and expansion of the signal. Okay. So, paano ginagawa yun? For example, no, I've discussed that on my class. Actually, you could retain that value. Pwede tayo mag-retain ng value, no, ng figure by placing a figure number. Maglagay ka lang ng figure number. That way, dun sa image mo na lumalabas, you'll have tab flaps of different figures and you could compare the signal. So, hindi ko lang nilalagay dito, puro figure 1 tuloy siya. But technically, I could declare that as another figure. So itong stem na to, I could declare that as another figure. Stem na to, I could declare that as another figure, and so on and so forth. No? O, ganun siya. I could declare that. No? That way, I'd have all the signals, graph of the signals under different tabs. Kasi lumalabas yun na overwrite yung figure 1 parate. So he automatically overwrites figure 1 the moment you're through with your command, no? O overwrite niyo kasi you did not specify if that will be figure 1, if that will be figure 2, etc., etc. You could have multiple figures there, no? That your MATLAB could actually display. Nakita ba? And you could actually save that under different tab flaps. Nakuha ba? Because whatever operation that we are actually doing is recorded here, no, on your workspace kung makikita nyo. Lahat ng operation na ginawa natin nandito sa workspace na given here on the left. Okay? Lahat yun na nare-record dito basically, no? Okay, so he records everything there. That which is why you could actually replay any command by simply pressing your up button, down button, di ba? So pag press ko yung up button, ayan, oh, ito yung mga nagawa ko na. O di ba? He keeps a record of all the operations I have done, all the commands I have done. So basically, I could go back to that command without typing it again, no? Kasi most commands under MATLAB are basically typed, no? So which is why if you're not very fond of typing like me, parang sobrang tamad mo mag-type, you could use that special feature nung MATLAB, no? Okay? So we've learned how to fold, we've learned how to shift already. Time scale naman tayo. So, ano ba yung idea ng time scaling? Time scaling basically means compressing your data or expanding your data. Okay? So, technically, sabi ko nga, you could declare the value of n where your signal will fall. Okay? Pwede yun. Dinideclare mo yun. So, pwede siyang gano'n, no? Which is manually done again, no? Kasi if you apply that concept, MATLAB does not perform any, there is no single command for MATLAB that performs that task. But you could again make MATLAB work like a calculator like this, no? That way, you could do that command on every single line, no? Pwedeng isang line, command ko, tapos he performs this, and then that's already the command for this. Nakuha ba? So basically, pwede naman yun eh. So under time scaling, for example, maglagay tayo ng example uli dito. Kunyari mag-graph ako. Okay. So this is obviously 0. This would be 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Parang ganyan. And then, palitan ko lang yung color kasi pag nagsusulat ako ng data, hindi nyo makita eh. Let's say on 0, I have that signal na amplitude ay 1. Okay, 1. Tapos dito sa negative 1, I have that signal na 0. Dito sa 2, I have that signal of 0.5. Okay, and then here, again on 3, I have a signal of this time, let's say negative 1. Okay, all the way to 4, let's say sa 4, meron akong negative 0.5. Okay, on the other side, dito naman sa negative side ng ating axis, let's say 1, tapos meron ako ulit 1 here, and then I'd have like negative 0.5. Ginagawa ko lang mas simple yung mga values. Actually, you could have any values here. Pero I wanted to keep it as simple as possible. So 1 tapos let's say negative 1. Oh, it should be longer. Yeah, negative 1. Ayan, no? When you do folding, so this is my, this is your x of n. When you do time scaling, let's say I wanted to do a time scale of 2n, x 2n. Oh, this is not a subscript. That is not a subscript. Okay. X2 of n. Basically, I'm getting the time scale and compressing it. Compressing the signal to twice. Okay. So meaning when you perform the process, the answer would now be like this. And you could just basically do this manually, no? Pwede mo namang gawing manually ito. But again, when you do it in MATLAB, typically you just need to alter the time scale, the values of x. Okay, yun lang gagawin mo. Okay, and again, you don't need to write a code script for that, no? Kasi iba, parang obviously they don't know how to do it. They just look for the internet, and then the internet provides them a script, and they don't know what that script is doing. Pero napakadali lang nung command, no? The command is simply, because you're doing it on discrete signals, limited only to the signals, it's actually fairly easy to make your MATLAB work like this na lang. As simple as this, no? Not basically creating a loop or command script pa. Hindi mo na kailangan yun. So, since this basically involves 2n, ang gagawin mo lang, whatever n value here, whatever n value there, signal, is placed at 2n. Nakuha ba? Okay, so twice nun, dun mo ilalagay. Nakuha ba? Like for example, sa 1, dito sa twice n ko, ang ilalagay ko rito is the signal at 2, which is this. So ang nasa 1 ko ngayon, so of course 0 is still 1, di ba? Kasi at 0, multiply ko ng 2, still 0. So ang amplitude ng signal ko rito is still 1. Then sa 1 ko ngayon, papasok yung signal na 0.5. Okay, because the amplitude of my signal at 2 is 0.5. Nakuha ba? Then yung nasa 2 ko dito, sa 2n, would be my signal at 4, which is basically negative 0.5. Nakuha? Okay, o ganyan, no? Tapos, dun sa left side ko, sorry, tama. Dito sa left side ko, yung mapupunta sa n equal to -1 ng 2n mo would be the value at -2, which is again -0.5. So dito, -0.5 yan. And my n at 2 here would be the one at -4, which is -1. So this would be, medyo humaba ng konti. Anyway, ayan, -1. This now would be my times. So ano nangyari? My original signal was compressed. Nakuha ba? And you might be asking, sir, what happens to the data that was in between? Okay? Ano ngayon nangyari doon sa mga data ko in between? Like for example, eto sir, yung data ko sa 3, yung data ko dito sa 1, ayan, yung data ko dito sa -3. Ano nangyari doon? They are lost. So despite whatever your instructor tells you that signal is not lost, under discrete signal, it's lost. Nawawala information. And you cannot recover that, no? Unlike yung analog signals. Yung mga analog signals kasi, nare-recover yun, nare-recreate yung signals na yun. Nakuha ba? Mga discrete signals to. You're dealing with discrete signals. If you compress that, those discrete signals are lost. And you cannot recover them from this given signal. Ito na yung signal mo ngayon, di ba? Kasi kinompress mo di ba? Ayan na ngayon yung lalabas na output sa'yo. You cannot recover this original signal anymore. Nakuha ba? Hindi yan parang analog signal. Okay? Sa analog signal kasi, if you compress a signal, ano mo yun, nare-recover mo yun. Yung mga nawawalang information na yun. Pero dito, hindi. Hindi mo siya marirecover. Because one bad thing about discrete signals that it's very difficult to interpolate. You won't know the pattern where the data was taken. Kaya nga kita mo, puro random. I just placed here random values and then he gave me random numbers. These are random discrete numbers that do not have any pattern, no? O basically, pwede ka rin mag-assign. Sir, ang gusto ko ako maglagay Ayoko ikaw naglalagay, sir. Parang ganun. I don't want MATLAB giving me numbers. I want to dictate those values. Ayoko nung ganyan Gusto ko ako yung nasusunod. Parang ganun ang gusto. Pwede mong gawin yun. You could make an array of numbers. 9 values as long as it doesn't exceed your given range. So I've specified there on your blackboard your range of values that you could actually use for your ang dami na nakasulat pero nakalagay dito create an amplitude. Nakikita niyo ba? Si sir kasi kung ano na yung sinulat. Create a signal with a maximum amplitude of. Hanggat di ka lumalabas sa amplitude value na yan, okay lang yun. Nakuha ba? Okay lang yun. Hanggat di ka lumalampas sa amplitude value na yan. So meaning, sir, can I dictate the values? Really? Oh, pwede ka mag-dictate ng values. Nakuha ba? As long as you don't exceed that value that you have. No? So for example, my seat number is 11. So my maximum value would be 3.3. Diba? So 3.3. As long as you don't exceed 3.3, okay lang. So pwede sir negative 5.8. Yes. Pwede ba negative 2.1? Yes. Ako naglalagay ng values na yun, sir. Oh, okay lang yun. Pero mahihirapan ka rin, no? Because you're gonna type that on the values and make an array of that value. Okay lang naman din yun. Okay lang yung dinidictate yung value. Nakuha ba? But the safest one is to simply do a random generation of numbers. That's easy. That's easily done. No? Kagaya nung ginawa ko. Okay? And then, nilagyan ko lang negative yun, no? Kaya kami minus. Okay? So, basically like that. No? So, pwede mo i-dictate yon. As I mentioned, this array, you could dictate that and you could declare that array. And use that array over and over. Nakuha ba? Okay. So, paano tayo magdi-declare ng time scale kay MATLAB so that you will eventually get these values. These values only. No? Nakuha ba? So, pwede ko i-dictate kay MATLAB literally yung values. Nakuha ba? Of the one I can plot on my graph. Di ba sinabi ko sa inyo? Just simply create an array. Nakuha ba? Okay, so anong gagawin ko? I want my -2, parang ganito no? Ang gusto kong mangyari, this last value, which is the one placed at my -4 right now, when I flip this value, okay, annotate ko lang. When I flip this array, ito yung array natin, nung flip ko yan, ito yung lumabas sa array natin. Okay? And I want this is at n equal to -4. I want this to appear at -2. Okay? I want to disregard this. I want this value to appear at -1. Nakuha ba? Disregard this. Nakuha ba? I want my 0 to be retained here. Nakuha ba? And I want my disregard this. Gusto ko i-disregard to. Ito, value na 2. Ito yung sa 4. Di ba? I only want to see all these values. Okay? And again, you could dictate that. Okay? So, paano yun? Magka-create ka lang ng array again. Nakuha ba? So, just manually create an array. Pwede naman ganun eh. Nakuha ba? So, paano yun? For example, create tayo. Let's call it y. Y, okay, is equal to an array of values. Okay? And I will copy all those values. Pwede naman ganun eh. Sabi ko nga sa inyo, pwedeng manually ilalagay natin. 0.0678. Nakuha? That's the first value. Okay? Then I do not want to consider the next value, yung susunod na value kasi I scaled it for 2n, di ba? Okay? So susunod 0.257. Sorry, 0.2537. Naduling ako, sorry. Ay, kasi ang dai-dai nakasulat kay sir. Teka lang, i-clear out lang natin to. You already know how scaling is done. This is called upscaling. Oh no, it's called downscaling. Sorry. Clear lang natin. Yan. Okay. So ayan, I'm dictating the values of my array, no? And then negative 0.2142. Okay. And then 0.0497. Okay. And then 0.3308. O yan na. Ito na ngayon yung laman ng array ng y. Nakuha ba? I-hold ko muna yung ano niya na. Ay, sorry. Invalid expression. Ay. Bakit nagkaroon ako ng invalid expression? Use parenthesis. Oh, sorry. When calling function or indexing a variable, use parentheses. Otherwise, check for mismatch. Ay! Sorry. Ano ba to? Row of values. And therefore, it should be like... oh no. Ganyan pala sa kanya. Oh, sorry. Oh. Yeah. Kasi array. Sorry. So dapat colon yung separation. It's not comma. Kaya nagkaroon ng invalid. So, ayan. So gumawa ako ng array. And I simply gathered all the values here on the ones I wanted to see. Nakuha ba? And then pwede mo i-dictate yung n. Again, no? Okay? So, let's say n. Maglalagay ako. Ano to? Integer value, no? So, again, n may be a range of value. So, ano to? Dahil na-scale down to 2, 2, 1, ang separation niya, 1, increment by 1, all the way to positive 2. Nakuha ba? And then, pwede ko ulit stem plot. Stem, and then, ano yung x ko? Yung x ko, yung n. Okay, comma, y. Sundan? Then, pa-plot uli natin. Ay, sorry. Ay, mismatch daw. Sorry. 1, 2, 3, 4. 1, 2, 3, 4, 5. Tama naman. Mali siguro yung array ko. Declaration ko ng array. Ay, toolkit to. Sorry. So, Simulink to. Sorry. Mali. Okay. O pwede naman pala yung time scope din. Time domain naman pala to. So, okay lang. Whether this is discrete or not. Pwede rin pala yun. Array plot displays array of vectors. Hindi ko makita yung command. Data logging scope, time scope. Ang haba. Ang dami kasi dito eh. Let's specifically go to signal operations. Meron pala siyang delay eh. Ito pala. Meron siyang pan-delay. Ito yung pang-shift. Delay yan sa kanya. Okay. And you could use this too. No? Pwede nyo rin gamitin to. Okay. Yung parenthesis is not used for arrays, but rather bars. Okay. Let's try that. Wait lang. Ito pala, may mga delay na pala eh. Kaso nga lang pang ano to eh. Simulink. I'll show you Simulink later. Okay? Kasi merong part ng activity that you have to do Simulink. So, papakita ko rin to later. So, dito meron na siyang command ng delay. Nagkakaroon siya ng delay ng fixed. Ano to? Delay or advance? Actually, if you place there a positive value of delay, so delay siya. If you place a negative value, magiging advance siya. Okay? So, typically like that, no? When you apply that signal operation. Kasi ano to, nasa signal toolbox. I'm using the category for the signal toolbox. No? You won't see this category unless you have that toolbox. I'm using the online version, which is why it has a complete toolbox. No? However, I cannot do any online application like voice recording here. Nakuha ba? Hindi ko magagawa yon unless I have the installed MATLAB. Okay, so try natin yon. Sinabi niya. So I'll just declare this as yung Y. No? Let's try that. And and then plot again. Hindi, magkaiba pa rin daw yung length ng rows. Bakit kaya? Tama na yung array, ibig sabihin. Anyway, I could declare that just like a stem, and then I'll just declare the range, -2. Pwede naman ganyan no? Incorporate ko na. Like that, comma, and then y. Mismatch talaga. Sorry. Okay. Okay. I am having problems with indexing anyway. The length of... So basically parang ganun lang din naman eh. So ang ginawa ko lang, I just changed the size and then I plotted these values. Parang ganun no. So pwedeng declare nyo ganyan as individual. Pwede naman yun kay MATLAB. Okay? Or like this, pwedeng ganito. Tapos actually paano ko ba kukuhanin yung values dito? I'll just get okay. I'll just declare that here anyway. Mhm. Kuhanin natin yung declaration kapag let me look into that. I could declare it as a matrix, di ba? Array of matrix. Yung array of matrix is already on your MATLAB, on the PDF, no? Nako ba? So pwede nating i-declare yan as an array of matrix, yung values. That way, it's easier to print, ano yan? What if y instead of space, line space? Actually, parehas lang yun. Pag nilagay ko line space. Okay. Line space. Actually, yung line space, spacing ng line. Pero magmi-mismatch pa rin ako. Okay. So anyway, teka lang. Declare muna natin as correct yung array. Baka nagkakamali ako sa declaration ng array values ng ating MATLAB. No? Mm-hmm. Separated, walang comma. Bakit? Ano nangyari ba? Isang column ba yung ginawa ko? Array of column ba yung ginawa ko? O array of rows? Yung bottom left po walang laman. Okay. Check natin. O nga no, yung y ko walang laman. O nga no. Bakit hindi nagkaroon ng laman yung y? So mali nga yung declaration ko ng y. Kaya nagmi-mismatch. Okay, so mali itong array declaration ko ng y. Ayusin natin. Let me declare y correctly. Ito. 6, 7, 8. Oo nga, no, walang value na sa lower left. Dapat may laman yung y ko dyan sa lower left natin. So, ibig sabihin, mali nga yung declaration ko ng array. Kaya nagmi-mismatch. Ayan, try natin to. Yung sabi mo. There, ayan, nagkaroon na nga ng laman. Tama. Ito na nga yun. And then I could just, again, type stem and y. And then, there, it plots it now. Okay, so mali yung declaration ko ng array. Correct? Ayan na, no? So here's the scaled version of my graph. So take note, pwede mo i-declare, wala pala siyang comma, yung array. I was looking at already on my PDF, no, checking the declaration of the array if that is correct. So kapag ka single row, oo tama, wala nga comma. Pag nilagyan kong column, that would be one column. Ng colon, it's a array declaration for a single column. It's not a declaration for a single row. Pero alam ko tama rin yun eh. Pwede rin siya eh. Anyway. Oo nga. Hindi. Ang column vector, semicolon pala. Semicolon yung separation ng bawat element. Okay. Tapos yung row array, row vector, walang colon. Walang semicolon. That's the correct array. So, chinek ko lang. Nagkakamali ako sa declaration pala. Okay. Ayan. So, that's the scaling, no? So, when we do expand this, pag in-expand ko naman siya, the concept is that the graph will be enlarged. So from originally -4 to 4, it becomes -8 to 8 if I do n over 2 scaling. Okay? So yung n over 2 scaling naman basically shows us that whatever scale that I have will be subdivided, will be multiplied twice the number of scales that I have. Okay? So, ganun siya. So, ibig sabihin ng times 2, basically compression. Yung n over 2, expansion. Okay? Na-expand ngayon. So, what do you place on those expanded scales that do not have values? They are simply zeros. So, nagkakaroon siya ng zero values. Nagkakaroon ng mga empty slots naman ng columns or empty values of amplitudes on those given values of x. Nakuha ba? Again, you could declare that here. So for example, ito, expand ko to ng n over 2. So again, ang gagawin ko lang, di-declare ko si n, okay, to be, babalik ko sa 4, -4. Okay? Kaso nga lang, mapupunta itong mga to, values na ito, at 0, 1, 2, 3, and 4. Parang igigitna niya parate. No? He always centers that because I did this format. Meaning the middlemost value is always placed at the center. That's the command there. No? When you do that array, you place always the middlemost value at 0, n equal to 0. Nakuha ba? So that's the format of the concept there. No? Nung process. Okay? So that's scaling. Tapos, you are also asked here basically to get, so ito pa yung mga operations, signal operations that you need to do. And again, the process there is to simply, the order of operation here, when you're trying to evaluate this so that you'll get the correct answer, no? Ang process is always shift, fold, and then scale. Nakuha ba? So, for example, meron akong ganito. Okay? What do I do there? You shift the signal first. Nakuha ba? Okay? So, I shift the signal, meaning n plus 3 first. Nakuha ba? Ayan muna. Isi-shift mo. Okay? And the usual concept is that ito muna. And then the next one is folding, which is yung negative. Okay? So, to make it understandable, I just use a different variable. So, gagawin ko lang kunwari, yn is equal to x negative n. Nakuha ba? Okay? And then I use another variable, let's say zn. And then this is the fold part, no? Ito yung folding part. Or flipping left, right. And then I scale this to 2. Okay? So zn would be like y to n. So this is scaling. Nakuha ba? Okay, and the usual process is basically you could get the correct answer here because if I evaluate for this is what you want, no? Ito yung gusto natin makuha. This is what we want. Okay? And what you do is evaluate this one first. And since this one is equivalent to substituted here, so lahat ng n dito is equal to 2n. So this becomes negative 2n. So substitute mo lang tong value na to dito. Okay? Basically like that, no? Ande, pakita natin. Siyempre, baka nalito kayo. Ganito na lang. This is what we ultimately want. This is my response, yn. Ang gusto ko, x negative 2n plus 3. Nakuha ba? Ito yung gusto ko mangyari. Okay? This is what I want. Okay? So, anong gagawin ko? Yung x of n ko muna, I shift it. Okay? Using any variable. Okay? Oh no, wag x. Sorry. Redundant yung x. Ito na yung x eh. Output eh. So, palitan ko lang. Magiging redundant eh. So, v. Okay? Tapos, ito yung yn, which is n plus 3. Okay? Tapos, let me erase this. Tapos, any variable ulit, for example, wn is equal to, ito yung shift. Wn is vn negative n, v negative n. Okay? And then, I use any variable ulit, let's say, t of n be equivalent to wn w2n. So this is fold, this is scale. Okay. So, and then all I have to do is basically substitute wn here, which makes this v of n equivalent to w negative 2n. Okay. Tapos yung aking y of n is shifted, which is eventually shifted to 3. So this would be uh, x negative. Sa substitute ko kasi dito, no? Yung aking w of n, which is now negative 2n. Negative 2n plus 3. Di ba? Which eventually is this one. Nakuha ba? So all you have to do is to fold first, then, shift first, then fold, then scale. Nakuha? So all you have to do is to show those individual process sequentially. And then after scaling, that's your final answer on that given operation. Nakuha ba? That's how you evaluate that. So if you were under my lecture, I already covered that and discussed that. No? Nakuha ba? Okay. What about the odd-even components here? Okay. Paano naman tong odd saka even component ng aking signal? The odd and even component basically is your original signal plus the flip signal. So meaning yung odd component ng signal mo is basically your original signal xn plus the flip signal divided by 2. Okay, tapos yung even component naman ng signal mo is your xn minus your flip signal over 2. Okay, or basically parang ano to no? Multiplied by 1/2. Ay, yun yung lalabas no? So, let me just erase this. Gawin ko lang 1/2. Oops. Ay. Nabura ko yung lahat eh. Binuha itong line na to. Kainis. Ito times 1/2. Yan, times 1/2. And technically, you could see that if I add the odd component and the even component, I should end up with the original signal. And notice that if I add 1/2 of this plus 1/2 of this is equal to xn, and this one cancels out. Diba? So I ended up with my original signal. That's the odd and even component. Nakuha ba? So, paano ko gagawin to? Flip left, right. Flip left, right. Tapos add mo lang doon sa signal mo. Nakuha yan? Na-get nyo na yung process? O ganun lang, no? Flip left, right, then add that on the signal. Actually, pag nag-add ka ng signal, basically plus lang siya. As simple as adding them. Parang yung x and y ko na ginawa ko kanina, no? Pwede ko i-add yun. Signal addition kaagad sa kanya automatically, no? Even if they have mismatched, ang gagawin niya doon, fill upan niya ng zeros. Okay? Lalagyan niya ng zeros yung mga areas na walang value. Kasi yung isa, negative 4 to 4. Yung isa, negative 2 to 2. Diba? O ibig sabihin nun, hindi equal yung length yan, sir. O lagyan mo ng zero. Automatic, lalagyan niya ng zero. Kung hindi niya lagyan ng zero, ikaw maglagay ng zero. Ganun lang yun. Kailangan fill upan lang yun. Kailangan equal lang yung length. Wait lang class. I have a call. Wait. I need to answer this. Okay, so I'm so sorry for that. Uh, we were disturbed while doing that. Okay, so let's do this now. Let's do this flip process and then get the even component and the odd component of our signal. Okay, and basically I will end with this. Ito na yung pinaka last part na muna. And then I'll teach you Simulink. Siguro ano na lang, next meeting. Anyway, you still have ano pa naman to no? April 13 ang submission. 12, sorry. April 12 yung submission. No? So typically, you still have time to do that, no? Yung Simulink, which is actually done on number 5. No? Kasi doon sa number 5, if you notice, ganyan yung nakalagay, drawing. Naka ba? So how would I interpret this drawing? Paano ko ma-interpret yung drawing? Eh, ang alam ko, mga signals na ganito, kagaya ng sinusulat ni Sir. No? Okay, so yeah, I'll show you how that is interpreted. Okay, using Simulink, of course. You could actually use a different approach there. Pero ang mas magandang process doon is to visualize that using that Simulink. Ano? Okay, so eto na muna. Odd and even component ng signal. Okay, so as seen from the formula, I'll simply add the signal from the flipped version of my signal. Okay, so let's go over to MATLAB. Clear ko lang yung drawing. Oh. Okay, so I'll just use the X value again here. Okay, that we previously have done. Ito yung mga X values natin. Okay, so I'll just declare Y as my flipped value of X. Okay. Okay, pwedeng pwede naman yung sige, neg X na lang. Negative ng X. Neg X. Oops, sorry. Yung flip left right ng ating X. Yung flip left right ng X natin. No? So, and then, ang gagawin ko ngayon, I get the odd X. Okay. Odd component. Let's call that odd X. Odd X is equal to, I just basically add the signals. Wala ako. Wait. Nakabukas eh. Sorry. Nakabukas dun sa window ko. Naligaw ako. Okay. Ano ba itong nakabukas na ito? Sasara ko lang yung mga activities pala ito. I'll just close this other windows. Dami. Okay. Okay, sinara ko lang yung mga unwanted windows. Okay, so basically, I know the negative of my x. No? So, add x pala yung minus. So that would mean x, my original signal, minus my negative x. Okay. So this is the odd, and then my even x. If x is equal to x plus negative x. Okay. There. Ay, sorry. Divided by 2 pa pala. Babalik ko ba ito? Hindi ko na pala ito may edit. Mali pala yung ginawa ko. Ulitin ko na lang. I'll just type it again. That way he overrides it. So divide by 2. There. Override me. And then even of x. Para ma-override niya ulit. Just declare it again. Yan, ang tama. And then I'll just declare this. Stem. Gamitin ko uli yung array na negative 4 to 4. I'll plot the add of x muna. Declare ko muna as figure. Para dalawa makita natin. Figure 1 tapos stem lumabas agad yung figure window. Hindi ko pa. Anyway, hindi ko kasi na-hold ng semicolon. Susunod, i-hold natin ng semicolon. Para hindi siya nag-execute agad. 4 to 4, comma, odd x. Yan. Then lalabas syempre yung, this is now the odd component of my graph. Okay, tapos figure 2, natin. Figure 2. Tapos lagyan ko lang ng semicolon, hold natin. Ang laman naman ng figure 2 would be stem o 4 to negative 4 ulit, negative 4, increment of 1, positive 4, even of x and x. So yun na. This is figure 1. Ay? Siyempre, nabura ko. Anyway, this is the even of x. We could just plot the odd of x using a different figure number. Okay. So, um, lagay ko lang sa figure 1. Ulitin ko lang yung command para makita nyo yung difference nung add tsaka even. I-stem plot ko yung add. Yan. So ito yung figure 1. This is the odd. This is the even. Okay? Nakikita nyo na yung difference? Okay? And generally speaking, when we plotted the actual x, di ba? Linat natin si x. Sabihin ko na lang figure 3 yun. Figure 3. Para makita natin yung figure 3 stem x. Stem tapos 4. Igitna natin ulit. 4, 1, sorry, negative 4. Negative 4, 1, 4, trace, tapos x. This was our original signal. This is our discrete signal. Ayan yung original discrete signal natin. And pag in-add ko yung odd and even, which is yung figure 1 is your odd, your figure 2 is your even. Okay? Ito yung add natin, figure 1, ito yung even natin. Signal. Dapat pag in-add ko yung dalawang yan, it should result into a figure 3 like this. Tama ba? Okay, so pakita lang natin again. I'll just use figure 4. 4. Oops, mali spelling. And figure 4, and then I will this time plot W. Okay, kuha lang tayo. W is equal to odd x plus even x. Okay. Tapos, I'll just hold that answer and then plot. Oh, stem. Sorry. Stem. Negative 4. 4. Comma. W. So let's see what the output waveform of this plot now is. And you will notice it's exactly the same as your figure 3. Yung figure 3 nyo, yun din, o di ba? In fact, here, you'd notice on the lower left, the values on my W is exactly the same as the values on my X. Ito yung X ko, tapos yung W ko. Is this. Di ba? Pareho ng laman. W and X. Di ba? Which eventually shows us that these are the odd and even components of your signal. Nako ba? Any signal has an odd and even component, even analog signals. So yung mga analog signals, merong odd-even components. Yung discrete signals, merong odd and even components again. And that's the basic formula you have there for odd and even component of X. So yung even is simply the signal X plus the flipped version of your X divided by 2. Yung odd version of X mo is simply your signal X plus the flipped version of X minus the flipped version of X all over 2. So that's the odd and even components of your signals. This is applicable for any signal. No? What's the difficult you could actually imagine if I add all the signals. Sinabi ko nga, no, if I add the signals, you would see that it it adds up to a whole part of my actual original signal. Because that flip version cancels out. Okay? What's really eventually will boggle your mind is that how is it that this component odd is simply my signal plus the negative signal over 2, which is basically a formula derived under your DSP. So actually, nasa book to, the derivation of how we came up, the book came up with a formula for your odd component and your even component of that signal. So that's the formula there. So simply follow that given formula, and basically you'll be able to determine the odd and even components of your signal. Nasundan? Okay, so I'll end at that and then show you the Simulink, demonstrate to you how Simulink is actually applied uh, on your MATLAB. Okay, and again, notice that this particular uh, process has a button there already on your MATLAB. Actually, sa akin, meron na kaagad. I do not know whether if you downloaded the Simulink, magkakaroon din kayo ng ganitong toolbar. Okay? But you could actually use that, unless you have that Simulink attached to your system, you won't be able to access this. No? So that means you have to download a package for this Simulink also. Again, I'm using the online version, which is why I have that Simulink here. But if you do not have that Simulink, you could actually download a version of that under MathWorks and install that on your MATLAB. Nakuha ba? So yung Simulink na yan. So tuturo ko naman sa inyo how to use that Simulink next meeting for the other number 5 on your activity. Okay, any question there? Walang question? Okay, so I want you to turn on your cameras for a few seconds so you'll be recorded within our session, which eventually serves as the attendance. No? Okay. Okay, so thank you very much guys for joining in our session. Thank you. Wala muna activity for this week. Next week nyo na gawin yung activity. Thank you, thank you. Stay safe, stay healthy. Have a holy week and safe week. Okay?
Thank you po, sir.
Thank you guys. Yes, you may log out of the
Thank you, sir.
Thank you po, sir.
Thank you, sir.
Thank you.
Sir.